Assalamualaikum to Dr. Wahyono. Today we will present about FEA analysis of bike frame. I'm Nadiana binti Abdul Rahman, second Syarah Haidi and the third is Azri Abadi. Our objective is to design one TT bike frame using SolidWorks. Second objective is to conduct FEA analysis based on TT bike frame. The third is to improve the result from the FEA analysis. This is design of TT bike. It has handle load, it has saddle load and the pedal load. For the methodology, first is define objective, second problem statement, third we do the literature review based on journal and the article. Next we select the material properties, then create 3D CAD modeling. Then we boundaries condition on the load. Next we generate the mesh and run the series. After run the series, we get the result and validate the result. For the 3D modeling creation a detailed 3D model of the TT bike using SolidWorks. Then we assign a material properties to the bike frame. Common properties include carbon fiber composite, aluminium and titanium. Then we generate a mesh that is fine enough to capture stress concentrate. Refine the mesh in area with the high straight gradient such as joint and mountain point. This is our machine. So the element of the machine is 147078. The number of node is 254117. The material that we use is carbon fiber, which is 230 GPa. Next is the boundary condition. So for the boundary condition of the strain, we apply a boundary condition at the point where the frame is connected to the component or assume during the analysis, such the bottom bracket BB area. Next, we assume the rider is 60 kg, exert the considerable load on the contract point, then effect the frame structure integrated. So this is our A and B is our fixed point boundaries.
So for analysis type, there will be three conditions. So the rider weight is 60 kg until 65 kg. Then we're assuming it 600 Newton. So at the pedal moment, there will be 490.5 Newton. At the pedal distance, which is the distance from pedal is 0.0165 meter, and the pedal moment is total up to 8.093 Newton meter. So there will be three conditions. The first one is relaxing condition, which is there will be 600 Newton from the saddle. There will be the aero position, which is 450 at the handlebar and 150 at the saddle.
For the preliminary result is equivalent stress von Mises. So the maximum deformation, the value is 0.014 mm, which is the red color. Indicate where the frame is most flexible or weakest under the given load condition. So the minimum deformation is 0.0015875 mm, blue color. Indicate part of the frame under minimal deformation. So the total deformation visualization, the total plot illustrate how much the bike frame deform under the applied loads. Deformation values range from 0 mm blue to 0.014288 mm red. This color code model is essential for visualizing region of high deformation, helping to identify potential design weakness or areas that might require reinforcement. The material properties of carbon fiber ensure that the frame can handle significant stress without excessive deformation, maintaining structural integrity and performance. So for the maximum stress, the value is 2.545 bar is the red color. So indicates area with the highest stress concentration. So the minimum stress is 0.00515 H bar, the blue color, indicate area with the lowest stress concentration. So the equivalent stress von Mises, the FEA result is visually represented using a color gradient that signifies varying level of stress intensity within the bike frame. The stress value range from approximately 0.000515 H bar in the blue regions to a maximum of 2.545 H bar in the red region. Intermediate colors depict stress level between these extremes. Red region indicate the highest stress concentration and are critical for avoiding failure, while blue regions represent the lowest stress concentration. Intermediate colors show moderate stress level, typical under normal loading condition. Safety factor. The main display visualize the safety factor using a color scale, where blue indicate region with a high safety factor and red signify area with a low safety factor. The safety factor is a ratio of the material strength to the applied stress, and higher value implies greater safety. Minimum safety factor is 9.82, the maximum is 15.15, and the average safety factor is around 15.15. The bike frame has a high safety margin, with the minimum safety factor being nearly 10 times the applied stress in the most critical area. This suggests that the design is very robust and safe under the applied loads. However, areas with a relatively lower safety factor, despite being above typical engineering.